This is the continuation of notes from yesterday on the handout that says Lesson 4:4, Complex Numbers, Day 1. So we're going to jump down to where we skipped yesterday, which was discussing the powers of I at the top of the second page. So there's a pattern to the powers of I. So the powers means if you do I to the first, I to the second, I to the third, I to the fourth, I to the fifth. So I to an exponent, that's what we're talking about when we say powers of I. We're trying to figure out what that would be in simplified form. So remember two things. I is equal to the square root of -1, which we're not going to be necessarily using a lot in these problems. But if you square both sides, I squared would equal -1. And that's the one that we're going to be using quite a bit. So I squared equal to -1 will help us get rid of some of those i's. You never want to leave I squared in an answer. You always want to turn it into -1. Okay, so we're going to try to figure out what kind of how the pattern works. So I to the first is just I. Okay, I squared we know is -1. I cubed you can think of as I squared times I, because remember when you multiply like bases you add the exponents, and 2 plus 1 would be 3. Well, I squared is equal to -1, so that would turn into -1 times I, or -I. And then I to the fourth is I squared times I squared, so that would be -1 times -1, which is +1. Now this pattern will continue. I to the first, I to the second, I to the third, I to the fourth, I to the fifth, I to the sixth, etc. goes to the pattern I, -1, -I, 1. I, -1, -I, 1. So for example, I to the 1, 2, 3, 4, 5, 6 would equal -1. I to the 7th is equal to -I. I to the 8th is equal to 1. Now you'll notice that whenever you have an exponent that's a multiple of 4, whenever there's an exponent that's a multiple of 4, it'll equal 1. So we'll kind of try to break it down, the power into a multiple of 4 and then whatever leftovers there are. So I have a little chart here that will kind of help you sort of count off what the powers of I are. And on our chart we're going to make the right side equal to +1, the left side equal to -1, just like on a number line. And then at the top, this is going to be like our I direction. The top will have I, and at the bottom we'll have -I. So that kind of makes sense because it's positive up and negative down. Now, if you were going to count off I to the 11th, for example, you could say I to the 11th is I to the first. You always want to start here when you're counting because that's I to the first power. So I to the 11th would be I to the first, second, third, fourth, fifth, 6th, 7th, 8th, 9th, 10th, 11th, and 12th. Oops, I was supposed to go to the 11th, so backtrack that one. So I'd be stopping here. So I to the 11th is equal to -I. Okay, so you can really just literally sort of count it around for problems with sort of small exponents. So let's say you had I to the 19th. No, let's go 21st. Okay, so you would start again at I to the first, second, third, fourth, fifth, 6th, 7th, 8th, 9th, 10th, 11th, 12th, and notice that every time you end up in a multiple of 4, you're over here. I to the 4th, I to the 8th, I to the 12th, all ended up over here. So 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th, and 21st would put you up there. So I to the 21st is equal to I. Now, the way that works with, kind of in general, and especially if the numbers are larger, the exponents are larger. And notice that we're going to be going this way, counterclockwise, just like you count off the quadrants counterclockwise. But remember, again, your starting point would be at the top there for I. Now we're going to talk about how you can kind of break down the ones that have exponents higher, larger numbers. You always want to break it down into something that's a multiple of 4 and then a leftover. So for I to the 5th, what's the largest multiple of 4 that goes into 5? Well, that can be I to the 4th, and then you'd have 1 left over I to the 1st, right? Because 4 plus 1 gives you 5. I to the 4th is equal to 1. Okay, up here in our list. I to the 4th is equal to 1. So that's a nice simple one. That's why any multiple of 4, I to the 8th, would also be equal to 1. Any exponent that's a multiple of 4 will just be 1. So we can then replace the I to the 4th with 1, and 1 times I would be I. Now again, I can count it up here, and I can say I to the 1st, 2nd, 3rd, 4th, and I to the 5th is equal to I. Okay, so that verifies that is correct. Okay, how about I to the 16th? Well, that's a multiple, 16 is a multiple of 4, so that would be I to the 4th, I to the 4th, I to the 4th, I to the 4th, or I to the 4th. Remember when you do a power to a power, you multiply the exponents, which is just 1 to the 4th, or just 1. Now, you really don't need to show all that work for this problem. You can simply look at that exponent and say, oh, look, it's a multiple of 4. So therefore, I know it's equal to 1. Now, again, if you were to count it off in the little chart here, it would go I to the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9, 10, 11, 12, 13, 14, 15, 16. The multiples of 4 end up on the right side over here equal to 1. Okay, and I'm going to write over here the multiples of 4 because that's kind of important that we know. Multiples of 4 on exponents. It's always going to equal 1. They always land over here. Okay, I to the 23rd. Now, a multiple of 4 that is less than 23, but we want the biggest one. The biggest multiple of 4 less than 23 would be I to the 20th. And then how many do we have left over? Well, we'd have an I cubed left over. Now, I to the 20th is a multiple of 4, so it's just going to be 1. And then what's I cubed equal to? Well, if we know that it goes I negative 1 negative I1, I cubed is equal to negative I. Or I can look up here and double check and say what's I cubed equal to? I to the 1st, I to the 2nd, I to the 3rd. It's equal to negative I. So this is equal to negative I, which is multiplied by 1, just negative I. Now again, we can count it off up here and say I to the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 would end up down here. So I to the 23rd would be down at the bottom. Okay, so I to the 23rd is negative I. And then our last one, I to the 50th. It's going to be I to the, again, a multiple of 4. It's less than 50. The biggest one would be 48. How many are left over? I to the 2nd. I to the 48th is equal to 1. What's I squared equal to? I squared is equal to negative 1. Remember that we started the lesson up here with reviewing that fact. I squared is equal to negative 1, or you can also look at the chart here. I squared, here's I to the first, here's I to the second. That's equal to I squared. So I squared is equal to negative 1, and that means I to the 50th equals negative 1. Okay, now again, the whole idea is an expression is considered unsimplified if the exponent is larger than 1 on your I. So you can leave i's in your answer. You cannot leave I squareds, I cubes, I to the fourth, anything higher should not be left in your answer. So it's considered unsimplified if you have an exponent that's higher than 1. Now again, exponents that are multiples of 4 will come out to be just 1. So if it's like I to the 16th, that's just 1. But if it's not a multiple of 4, you want to take out the multiples of 4 and then use the leftover to figure out whether your answer is going to be 1, I, negative 1, negative I, or 1. Okay, and then something that's a little bit simpler down here is going to be the idea of multiplying two imaginary numbers. So when you're adding or subtracting, you're going to notice that the ones we talked about yesterday, you will see this symbol in the middle. That's a plus, and this one says minus. Okay, that's adding and subtracting. If there's no symbol in here, it's understood to be multiplication. And when you're multiplying, you have to treat the two imaginary numbers just like you would if they were binomials. Now again, remember I told you that I is not a variable, but it kind of acts like a variable sometimes. So when we multiply, we're going to have to FOIL. So first, 8 times 2, 16. Outer, 8 times negative 3i would be negative 24i. Inner, 5i times 2 would be 10i. And last, 5i times negative 3i would be negative 15i squared. Okay, I times I is I squared. Now, we're allowed to leave i's in the answer. We're not allowed to leave I squared in the answer. So anytime you see an I squared, you want to go, whoop, get rid of that. I squared is equal to negative 1. So that number out there is really, because you have the negative in the front multiplied by the negative 1, this is really a positive 15. Okay, and then we can combine like terms. So 16 and 15 would be 31. And then in here, our negative 24i and our positive 10i is negative 14i. Now again, it's all right to leave an I in your answer. You don't want to leave I squareds. So 31 minus 14i would be your final answer. Okay, now again, on this problem, number 14, you want to look and say, is this adding, subtracting, or multiplying? There's no symbol in the middle, which means we're going to be multiplying. So when we multiply, we'll FOIL. Oops, sorry about that. We'll FOIL, and we'll have negative 6 times 5 is negative 30. Negative 6 times negative 3i is positive 18i. Inner is 2i times 5, which is 10i. And last is 2i times negative 3i, which is negative 6i squared. I squared is equal to negative 1. And on both of those problems, the previous example and this one, we happen to have a negative in the front multiplied by negative 1, so it's becoming a positive 6. But if your last term here happened to be a positive 6i squared, it would turn into a negative 6. Remember that the I squared simply changes the sign in front of the term. Okay, and then if we add our like terms, negative 30 plus 6 is negative 24. And 18i plus 10i is plus 28i. And that's our final answer. Again, it's okay to leave an I in your answer. You do not want to leave I squareds, I cubes, I to the fourth, any exponent higher than I to the first power. And that's an answer that's an imaginary number because it has a real part and it has an imaginary part. And this is the end of this particular lesson.